Hello and welcome back to Aviation Heavy. Go where you feel the most alive. Today we are here to bring in front of you the concept of frangibility. As you all know, within the runway strip there are many equipments and installations to be installed to provide air navigation aids to the aircraft, which needs to be very frangible. So, in this video today we'll understand the requirement of frangibility into the object, the concept of it and design of it. So, with the help of Anvisha Pal, I have made this video and presenting it to you. So without any delay, let's get started.
At airports, various visual and non-visual aids, example approach lighting towers, meteorological equipment, radio navigational aids, are located near runways, taxiways and aprons, where they may present a hazard to aircraft in the event of accidental impact during landing, takeoff or ground maneuvering. All such equipments and their support should be frangible and mounted as low as possible to ensure that the impact does not result in the loss of control of the aircraft. This frangibility is achieved by the use of lightweight materials or the introduction of breakaway failure mechanism that enables the object to break, distort, or yield under impact. Now, what are obstacles? Obstacles are defined as all fixed objects or part thereof that are located on an area intended for the surface movement of the aircraft or that extend above a surface intended to protect an aircraft in flight. But the very first thing is that the first objective should be to sight an object so as that it does not become an obstacle. Nevertheless, certain airport equipment and installations, because of their function, must be located in an operational area. All such equipments and installations as well as their support should be of minimum mass and frangible in order to ensure that the impact within the aircraft does not result in a loss of control of the aircraft, or it should not damage the aircraft up to so extent that which is too costly for an airport operator or an airline operator to maintain. So now we need to understand some definitions. Frangible object: an object of low mass designed to break, distort or yield on impact so as to present the minimum hazard to aircraft. Impact load: a sudden application of load or force by an object moving with high velocity, in this case especially aircraft. Breakaway or failure mechanism: a device which has been designed, configured or fabricated in such a way that is very sensitive to one type of loading, usually resulting from a time dependent dynamic impact, but immune to the normal environmental and operational loads imposed on the mechanism during the lifetime of the structure. The breakaway mechanism can be designed in conjunction with the joints of the structure and or designed independent of the joints of the structure. Impact energy: the energy required to break an object, distort or yield when subjected to impact load. So in this diagram, here you can see the design of the bolt. It is not same as top and at the bottom. Here we have introduced this cut. This cut helps these bolts to get shear off on an impact load. So whenever an aircraft comes and hit the pole immediately falls just because the bolts fail from here. Moreover, the material of this pole is not so heavy. In fact, these two hold the center one so as to break in the case when the aircraft hits it with a high impact force. Some of the important regulations. Annex 14, Volume 1, Chapter 9 also specifies that an equipment or installation required for air navigation purposes which must be located on or near a strip of a precision approach runway Cat 1, 2, 3 and which is situated within 240 meters from the end of the strip and within 60 meters from the extended center line where code number is 3 or 4 and 45 meters from the extended runway center line where the code number is 1 or 2, penetrates the inner approach surface, inner horizontal, inner transition surface or the bulk landing surface should be frangible and mounted as low as possible. Further, Annex 14, Volume 1, Chapter 9, same chapter, specifies that any equipment or installation required for air navigation purposes which is an obstacle to operational significance in accordance with 4.2.4, 4.2.11, 4.2.20 and 4.2.27 of the annex should be frangible and mounted as low as possible. Now let's see what are the instruments which are installed near the runway which should be of a frangible nature. Airport equipments and installations which, because of their particular air navigation function, have to be located in the operational area include visual approach slope indicator system, elevated runway, taxiway and stopway lights, approach lighting system, signs and markers, wind direction indicators, instrument landing system, glide path, monitoring antenna, microwave landing system, antenna, anemometer, celiometer, transmittometers, and some kind of fencing. Now we'll study about the frangibility requirements. What are the requirements for an equipment being placed near the runway to get a frangible character? Equipment and its supports located in areas described in the previous slides should be frangible in order to ensure that they will break, distort or yield in the event that they are accidentally impacted by an aircraft. The design material selector should preclude any tendency for the components, including the electrical conductors, etc., to wrap around the colliding aircraft or any part of it. It is very clearly mentioned that the equipment we are designing to get frangible should not have the tendency to wrap around, because when something is wrapping around the aircraft, it will further damage the aircraft and giving a even worse condition to the accident. A frangible structure should be designed to withstand the static and operational wind or jet blast loads, meaning whatever we are designing should take the normal atmospheric condition and jet blast loads with a suitable factor of safety, but should break, distort or yield readily when subjected to sudden collision of a 3000 kg aircraft airborne and traveling at a speed of 140 km per hour or moving on ground at 50 km, meaning that it should bear the atmospheric load on the jet blast load, but when there is an impact by an aircraft, then it should break readily, immediately, in that fraction of second only. Third, the frangibility of the design should be proven either by means of full-scale test, computer evaluations, or by calculation based on the comparison with similar already proven structures, possibly supported by additional component tests. Basically, there are three main design philosophy which are kept in mind before designing an equipment. Equipment located near runways and taxiways should be designed to be frangible in order to limit the hazard to aircraft accidentally impacting them from any direction, either in flight or during ground maneuvering. Impact may affect flight safety in three ways. The aircraft may lose momentum, the aircraft may change direction, the aircraft may suffer structural damage. So we have to keep these three things in mind and then design that at the time of impact, when and at what rate the equipment should be broken, because if it is not happening in that particular fraction of second, then it will further damage the aircraft, which will be more costlier to manage. Now the design philosophy. The amount of momentum lost is mathematically governed by the integral of the force over time, which means the magnitude of the impact load and its duration should be of as minimum as possible, meaning the amount of force applied by the aircraft, and for the time being it is applied, it should be of very less time, because as the time increases, the impact of the force which it has created on the object is increased. The structural damage to the aircraft is related to the amount of energy it requires to move the object, meaning the more number of time the aircraft is in contact with the object, the more damage the aircraft is getting with the object. The structural damage of the aircraft is related to the amount of energy it requires to move the object or part of it out of the way and should therefore be limited. This energy can be broken down into following components: energy required for plastic or elastic deformation of the obstacle or part of it, energy required to accelerate the object or part of it up to at least aircraft velocity, meaning now the object has broken from its major part and is going away with the aircraft. The energy to activate the breakaway or failure mechanism. Note, the structural damage to the aircraft is also related to the contact area between the aircraft and the obstacle through which the energy transfer takes place. A larger contact area is shown to prevent obstacle cutting deeply into the aircraft structure. So, in order to meet the frangibility requirements, different failure mechanisms can be applied, such as modular design and one-piece design. Number one, the modular design. In this structure should contain breakaway or failure mechanism which apart and together requires only a minimum amount of energy for their activation. The concept permits moving the least amount of mass out of the way of the colliding aircraft. The sequence of events is easier to predict as the structure behaves in a brittle way, disintegrating preferably at small deflections. It also reduces a minimum the possibility of a wrap around effect. One piece design. In this, the frangibility must be guaranteed by a complete failure of the structure, which is achieved by the random failure of the structure members instead of by failure of predetermined breakaway or failure of mechanism. This implies that eventually the entire structure will be involved in the impact, resulting in a relatively high value of kinetic energy required to move the structure out of the way. Therefore, this type of failure mechanism seems to be situated only for a lightly loaded structure, that is, those meant to be carry low mass equipment. Moreover, due to the continuous nature of the structure, the sequence of the event is difficult to predict, and tendency to wrap around aircraft should be considered an additional hazard in this. Another way of making an equipment frangible is by making its connection frangible. So, in a frangible connection design, frangibility is incorporated in the connection, which carries the design load but fractures at impact. The structural member is not designed to break, but rather to transfer the impact force to the connection. Some of these are described as below. So, first we'll talk about the fuse bolts. Here we can see the fuse bolts. Now, the member design, this is the member. It is not designed to break, but these bolts are designed to break. So on impact, this will shear off and the whole structure will fall. This is also done because we can bear the cost of this bolt, but if the structure gets heavily damaged or breaking away the whole structure is more costlier in the both ways, in order to repair it and or to buy it a new one. Special material bolts. In this, as you can see, there are different materials of bolts used. So for example, if you are making two connections, two rods joining, and if you join them with a weaker bolt, so ultimately it will break from the weaker bolt part. So this is what the special material bolts are. These are made from special materials which are designed to break away first rather than the breaking the whole structure. The next is the tear through fasteners. Now in this you can see the picture. Now these two plates are now fastened with the help of a bolt passing by. Now if we apply a tension this side and this side, this design will break and we can achieve a break in the mechanism. So this is how it functions. The next is tear out section. Connecting gussets plates can be designed in with notches that will tear out with the member. In this type of connection, the fastener does not break, but instead it is used to pull out the section of the gusset plate. Fatigue life and manufacturing quality are the primary design of the consideration. So this is the last slide, and I just wanted to emphasize that this is the runway edge lights, and see how the design is made. Here we have introduced the frangibility. On hitting by the wheel of the aircraft, the upper part of the light will shear off and this part will remain on the surface. This is the ILS localizer, and you can see all the poles are frangibly attached by the surface. So on hitting, all the poles will fall rather than damaging the aircraft. This is the PAPI, and you can see the PAPI is frangibly attached by the surface with the bolts. Thank you all, and I hope that the frangibility concept is now clear in your mind. Any questions you can further comment it down, and Aviation Navy will surely help you with it. I am Shantanu taking my leave. Go where you feel the most alive.